For the first time in centuries, researchers have uncovered what's believed to be Jesus' tomb inside the Church of the Holy Sepulchre.
My knees are shaking a little bit because I wasn't expecting this.
Below the heart of Jerusalem, under the stone worn smooth by centuries of footsteps, scientists focused on the ground itself. What do you think stays preserved in a place that is visited every day by pilgrims, priests, and tourists? When small sections below the shrine were opened, the soil, rock, and remains told a good story.
The slab of marble on the top of what's believed to be Jesus' tomb.
About how the area once looked and how it was used. Gardens, burial customs, repairs, and changes over time all left marks. Why did these details catch the attention of the archaeologists? The Old Jerusalem. Jerusalem sits on layers of human work and memory. Streets, walls, and small houses grew over long years. In the 1st century, the city was under Roman control. Roman builders cut stones from nearby rock to make buildings and roads. Those cuts left flat faces in the bedrock and open places where blocks had been removed. Later, families and workers used some of those hollowed areas for storage or for small family burial rooms. The reused spaces often include simple shelves or shallow hollows where bones were placed. After a period of unrest, the Roman Emperor Hadrian rebuilt parts of the city in the 2nd century. He changed the streets and altered landmarks. That work raised ground levels in places and covered older surfaces with new paving. 2 centuries later, the Emperor Constantine and his mother, Saint Helena, sponsored a program to mark sites tied to Christian memory. They set up churches and chapels that drew visitors from near and far. Over time, a large church grew at a spot long honored by communities. Pilgrims and travelers left letters and descriptions that help today's archaeologists track how the place changed. Early accounts mention chapels, altars, carved stones, and the small shrine at the center of the complex. Over the centuries, many rulers repaired and rebuilt parts of the site. The Crusaders added chapels and adjusted layouts to fit their needs. Ottoman and later authorities carried out repairs with the materials and methods of their day. Builders often reused carved blocks when new stone was scarce, which means older stone appears inside later walls. A tight city like Jerusalem sees frequent reuse of space. A workshop may become a house. A quarry may become a cellar. A burial space can lie under a chapel built centuries later. Soil levels shift when builders add fill or raise floors to support new roofs. Small shifts of a few centimeters can move older surfaces below later ones. That closeness of time makes recording essential when specialists examine the ground. Work at the site today happens with both science and respect. Church leaders, city officials, and conservation experts set rules before any work begins. Often, the work begins because floors need repair. Replacing a worn tile may reveal older stone, compacted soil, plant remains, pottery pieces, or tiny bone fragments. Field researchers use hand tools and soft brushes to clear soil in thin layers. They photograph each step and label every sample so the origin of each piece is clear. Records from earlier studies help place new observations in a longer story. Old maps show how streets and plots shifted. Historical photos record earlier repairs and past layouts. Conservators assess which parts of the building carry structural loads and which parts are decorative. That information guides where they may dig and where they must leave things in place. Residents and clergy follow the work closely because the site remains a place of prayer and visits. Archaeologists coordinate to avoid major disruption of services and to protect sacred space. Public notices explain the aims of the work in plain language. Outside researchers review lab reports so the wider public can see how dates and plant lists were set. This mix of local care, long records, and modern methods helps specialists place small pieces into a clear timeline without rushing to strong claims. Each season of work adds a few items to a larger puzzle. The pattern of stone cutting, reuse, and garden soil fits the normal rhythms of families and builders who lived here across centuries. How can a garden and a shrine sit so close? The answer lies in layers. Tiny patches of old soil can survive under later floors, preserving seeds and pollen that speak to the plants once nearby. Proper details and laboratory tests then show which species grew there and help map the sequence of human use. The small shrine called the edicule has protected the older ground below, so archaeologists must work slowly and with advanced methods. But what secrets could these fragile layers reveal beneath centuries of stone and prayer, treasures, messages, or something unexpected? How they worked. Working under a sacred floor takes care, planning, and respect. A team from Sapienza University of Rome led the project. Professor Francesca Romana Stasola guided the group on site. The work began when church leaders asked for repairs to worn floor tiles. Those repairs gave a rare chance to look below the small shrine called the edicule. Skilled workers used brushes, small trowels, and wooden picks. They cleared thin layers of soil by hand to avoid harming the old stone. When a new surface or item appeared, team members stopped to record every detail. They took many photos, made visible sketches, and wrote deeper details such as the shape, color, and depth of each layer. Each sample was labeled with a number that showed exactly where it came from. That label traveled with the sample to the lab. Keeping that link between the spot and the sample allowed scientists to read the order of events under the floor. They also set up a small on-site lab to clean fragile bits. Conservators checked stones and metal before any item left the place. Non-invasive tools helped guide the work. Ground-penetrating radar gave a rough image of what might lie below without heavy digging. Photogrammetry helped the team build a three-dimensional model from many photographs. These tools let the team see the shape of the space and plan how to dig without risking damage. Daily planning was taken seriously. Each morning, the leader met the crew and set tasks. Some people took measurements, others excavated short sections. A small group packed and labeled samples for the lab. They agreed to stop work when religious services took place, so worship was not disturbed. Clergy and guides received briefings so they knew how the work would affect visitors and worshippers. When human bones appeared, the team followed laws and church rules for respectful handling. They captured the context and left most of the bone in place, if the law required it. Small, loose bones that could be removed for study were packed with care and sent to specialists under the correct permits. Metal fragments and small carved stones were treated by conservation specialists who cleaned and stabilized them. Information from the field described not only objects, but also the soil itself. They recorded whether the soil was loose or hard, dark or pale, and sandy or clay. These details give clues about how the ground changed over time. A thin, dark layer with tiny roots might show a patch where plants once grew. A packed, pale layer might show a floor or a work surface. Writing these simple details helps labs choose the right tests. Samples that contained tiny seeds or pollen were kept separate and dry. Technicians used small tweezers and sterile tools to avoid modern contamination. Some samples were sent to botanical specialists who used microscopes to identify seeds and pollen types. Other samples went to labs for dating. The lab tests gave age ranges that helped place layers in time. Outside experts reviewed files from the field and lab results. They then shared the technical reports with specialists at universities and museums. Reviews and outside checks are a normal part of the work, so that conclusions rest on many views. The project leaders also released public summaries to explain the aims and the steps to the people and pilgrims. The archaeologists used short written forms for every action taken on site. Each action had a code and a short description. That system reduced mistakes and helped map the work accurately. When a puzzling object appeared, they halted work in that area until a specialist could assess it. Stonemasons, metal experts, and palynologists visited the site when their skills were needed. Working under the edicule required an extra level of care because the structure is sacred and fragile. Builders used temporary supports and protective boards to keep the shrine safe while staff moved small amounts of soil. Archaeologists also set limits on where they could go so as not to disturb burial spaces that the law protects. Media questions came through a press office so that messages were clear and controlled. The press summaries aimed to state facts only, avoiding speculation. They also published long technical reports for scholars who need the full record. Overall, the effort combined a careful field method, careful recording, and lab science. That mix allowed the team to read layers of human activity under the floor without rushing. Each small step was planned to protect the stone, respect worship, and produce records that other experts could check. This care also helped city officials plan repairs and helped museum staff consider how to show clear displays for visitors who want to see the science behind the work for everyone. But as they peeled back each layer, something unexpected began to emerge. Traces that hinted at a story no one anticipated. Could this small shrine hide secrets even older than the city itself? What they found. Those archaeologists worked under the small shrine using their hands. They cleared thin layers of soil so that each layer could be seen and recorded. When a new surface appeared, the crew stopped to take pictures and to make sketches. Every sample received a tag with a number and the exact depth from where it came. That label traveled with the sample into the lab. They first saw flat faces in the bedrock where workers long ago had cut blocks for building. Those straight cuts match places used as quarries or as stone workshops. Later, hands used some hollow spaces for small family burials. In these pockets, the team found plaster traces and shelves for bones. These simple features show a burial practice that used small rooms cut into the rock. Soil above the carved stone held light organic pieces, such as olive pits and grape seeds. Specialists later examined these pieces to confirm their shapes. Tiny pollen grains came from thin soil samples and showed which plants once grew nearby. The mix of these plant traces points to trees and to vines near the spot long ago. Close to the shrine, the crew exposed carved marble fragments and a round marble slab that may be a base from an earlier feature. Some stones bore marks from old tools. In other layers, the team recorded thin floors of crushed stone and patches of old mortar where builders had repaired a surface. Small potsherds and lamp fragments lay in closed pockets that offered general dates for the layers. In one place, a thin dark band with tiny roots looked like a patch where soil had once held plants. Nearby, a thin layer of ash suggested a short burning event or simple debris from daily life. Small metal fragments were packed for special cleaning by conservators. Wood chips were wrapped in acid-free paper and stored for later study. The order of layers showed reuse in sequence. First, the rock was cut and shaped. Then people used some hollow spaces for burial. Over those hollows, soil gathered and plants grew. Later builders raised floors and set new walls above older patches. Where carved stone appeared, reused pieces had been set into newer work. They took many small soil samples and labeled each one with the field code. Botanical experts later measured the seeds and compared them to known species. Pollen charts listed the most common plant types. Pottery and coins helped give broad dates to some layers. The group working on the project did not claim that any single object belonged to a named person. Instead, the record showed how people used the place across many years. The mix of stonework, burial space, garden soil, and later building creates a clear sequence. That sequence helps explain why a memory of a garden could exist near a small shrine later on. Researchers still discuss the details. More samples from nearby spots will test if plant traces cover a larger area or a narrow patch. For now, the pieces recorded under the shrine give a layered view of work, life, and care in one place over many years. Future studies can add more detail by testing seed DNA to see varieties and by mapping more samples across the broader site. If seeds show cultivated varieties, that may point to household gardens. If seeds match wild types, the story will be different. Soil chemistry tests can show if people added compost or used the ground for planting. Small differences in mortar chemistry can mark repairs by different builders and in different centuries. The round marble slab beneath the later stone may have supported a small column or a decorative feature that belonged to an earlier structure. Tool marks on some blocks match styles used in known periods and so help place those pieces in time. In short, the record gives concrete traces of daily work and of household use. Small seeds and pollen show what grew nearby. Stone cuts show where builders once labored. Pottery and coins mark general dates. Viewed together, these elements tell a story about how one spot served different needs over time. The careful record made by the team means other experts can check the work. Open review by other researchers will refine the order of events and will place more samples in time. For now, the layers under the shrine display a long history of stonework, small burials, garden soil, and later building. That picture comes from work that has been done well with simple tools, accurate information, and lab study. People can follow those records when they have published full reports. For now, the list of plant types and the mapped layers give researchers and the public a way to see what the ground under the shrine holds today. But what secrets do these tiny layers truly hold? Hidden for centuries beneath the shrine, could they rewrite our understanding entirely? Lab results. Tiny pieces taken from under the floor went to several labs for careful study. Labels on every sample showed the place and the depth. That chain of information lets lab teams return results that match the layer and the stone above it. How do labs turn bits into dates and lists of plants? One common step is to float the soil. Technicians mix soil with water, and the light organic bits rise to the top. Seeds and small plant parts are then picked from the surface, cleaned, and dried. A specialist looks at each seed under a low-power microscope and compares its shape to seeds in a reference collection. This work tells whether a seed came from an olive, a grape, a fig, or another local plant. Pollen was handled in a different way. Tiny grains need careful cleaning to remove modern contamination. Lab staff dissolve unwanted bits, mount the grains on glass slides, and count them under a high-power microscope. Each plant type shows a recognizable pollen shape. By counting many grains, the pollen specialist can list which plants were common near the spot at a given time. Dating the layers required more tests. Radiocarbon dating measures the amount of a carbon isotope in short-lived plant bits or charcoal. The lab converted the raw number into a calendar range using a standard calibration curve. That range gives a likely span of years rather than a single date. Another test looked at sand and mineral grains to see how long they had been in the dark. That optical test estimates the last time grains saw sunlight. Together, these methods place layers in broad time brackets. Experts also examined pottery sherds and coins recovered from closed pockets in the soil. Pottery styles change over time and help sort layers by century. Coins can provide a narrower range because they often carry dates or the image of a ruler. Lab technicians read these objects and shared how confidently each object ties to a particular time. Materials analysis helped with the stonework and mortar. Microscopes and simple chemical tests show what the mortar contains and how it was made. A marble fragment can be studied for tool marks that match the working styles of a certain era. Specialists in stone carving can spot whether a piece was cut with Roman tools or later medieval tools. Combining methods gives stronger results. If radiocarbon, optical tests, and pottery all point to similar times, confidence rises. If results differ, specialists discuss why and look for possible movement of objects between layers. Modern contamination and later repairs can shift small items, so labs report the degree of certainty for each sample. How reliable are these reports? Labs give ranges and a level of confidence. A radiocarbon result might give a range of several decades. An optical result often gives a broader window. Pottery can narrow the century, but rarely the exact year. Researchers publish raw numbers so other teams can check the math and suggest different models. Preparation for lab work matters. Samples traveled in sealed bags with the original label. Technicians logged temperature and handled steps to protect fragile bits. Tiny wood fragments were wrapped in acid-free paper. Metal pieces were placed in inert containers to avoid corrosion. Who does the work? Universities and specialized research centers host the machines and experts. Botanists, pollen specialists, chemists, and material scientists each studied parts of the record. Project leaders invited outside reviewers to read reports and suggest further tests. This review by others helps catch mistakes and improve interpretation. What did the labs show? The plant list included olive pits and grape seeds, among other local species. Pollen counts supported the presence of trees and vines near the area. Dating tests gave ranges that match an early 1st century context for some of the plant layers and a later date for reused stone and carved fragments. Material tests on mortar and stone show several phases of repair and reuse over centuries. Labs used understandable terms in their reports. They gave ranges, noted the limits of each method, and suggested follow-up work. They did not claim a single grave or a named person. What they did provide was a sequence of plant presence, soil use, and building phases that matched the recorded layers under the shrine. All lab work remains open to review. More samples taken from nearby spots will help test whether the plant traces are local or cover a wider surface. Archaeologists recommended more sampling across adjacent areas and clear public summaries so other scholars and the public can follow the evidence and the steps taken and updates. But could these seemingly ordinary traces hide a story far more extraordinary? Are we overlooking a secret buried for centuries beneath Jerusalem? What it means. The material recovered under the small shrine gives a clear sequence of human activity at one spot in Jerusalem. Cut stone faces show where workers shaped blocks. Small chambers carved into the rock held burials for families. Patches of soil carried seeds and pollen that recorded the plants. Later builders set new floors and a small chapel above these older layers. The order of these elements helps researchers trace how the place served different needs over time. Laboratory work and careful recording make the sequence readable. Botanical samples include olive pits and grape seeds. Pollen counts list trees and vines among the common types. Pottery shards and coin fragments provide time markers for some layers. Stone tool marks and the style of carved fragments show changes in technology and taste across centuries. Taken together, these lines point to a pattern without attaching a modern name to any single burial. What can be said with confidence? First, the evidence shows that trees and vines were part of the setting near the spot. The shape of seeds and the pollen mix support that view. Second, the carved niches and shelf-like cuts fit the use of small rock chambers as burial rooms. Third, later construction used older carved stone moved from earlier work, a common practice when builders reused available material. What remains uncertain? A single piece of material rarely proves a single event. Coins and pottery narrow a broad time range. Radiocarbon results and optical dates return ranges that need careful matching to the field record. Small items can move when later work disturbs older soil, so specialists check whether objects lie in the position where they were first placed. Where lab methods and field information align, confidence grows. Where methods diverge, researchers examine alternative explanations. How does this relate to early descriptions that mention a garden near a tomb? The botanical record supports the presence of planted trees or vines in the area in the 1st century period. That landscape match makes the early descriptions plausible as a portrait of local conditions. This agreement remains a landscape-level match. It does not provide a direct link to any single person named in written sources. The project also carries practical consequences for repair and study. Careful mapping of vulnerable soil and fragile layers helps planners choose repair methods that will not erase small traces. Conservation measures include temporary supports for arches and limited removal of floor patches when necessary. Knowing where organic layers remain guides conservators to avoid heavy machinery in those zones. Scientific recommendations point to more targeted sampling across the wider area. Wider sampling can test whether seeds and pollen appear broadly or only in narrow pockets. If botanical traces spread over many square meters, that points to larger cultivation. If they remain confined, that suggests a small garden or a household patch. Further analysis of seed morphology and DNA could show whether olives and grapes were cultivated varieties or wild types. Open sharing of data strengthens the work. Publishing raw lab numbers, sample codes, and methods allows outside specialists to check calculations and propose refinements. Review is a normal step to improve dating models and to test whether later repairs shifted items between levels. Public summaries, written in simple terms, help communities follow the results without speculation. Combining several scientific methods gives the best picture. When radiocarbon ranges, optical dating, and pottery types align, the timeline becomes more reliable. When methods disagree, researchers search for causes such as later disturbance, contamination, or mixing of layers during repairs. That cautious approach helps avoid overstated claims. The most robust conclusion from the combined record is a local landscape where stonework, small family burials, and small-scale planting occupied the same area before later builders erected a small shrine. This conclusion rests on soil, seeds, stone, and small artifacts, rather than on any single direct claim. Further work will refine this picture. Additional samples, more mapping, and wider publication will let other teams test the sequence. For now, the record under the small shrine gives a clear picture of an activity in one corner of Jerusalem. Researchers will publish updates as new lab tests are completed regularly. But what if the story hidden beneath the soil isn't just about ordinary builders and burials? Could there be secrets these stones are hiding? The new angle. Think of the site as a simple sequence. First, the rock was cut for building. Later, people used the carved spaces for small family burials. Over time, soil gathered and plants grew. Finally, a small shrine and chapel rose above those older layers. This view explains how different uses sat on top of one another in the same spot. Stone cutters left flat faces and tool marks where blocks were taken from the bedrock. Those marks match methods used in the 1st century near Jerusalem. Workers later reused some carved blocks to build walls or floors. Reuse is common in a city where new builders take what is handy. The round marble slab under the later stone may be a piece repurposed from an earlier feature. Tool marks on some pieces show older shaping, while other pieces carry repairs from later centuries. Small rock chambers show where people placed their dead. These chambers often had simple shelves and traces of plaster. The burial cuts sit below thin layers of soil that later held plant material. Seeds and pollen recovered from those layers include olive pits and grape seeds. These plant types fit a local garden or a household plot rather than a large farm. The presence of both olive and grape traces suggests people used the ground for food production close to where they lived. Soil chemistry and thin root traces point to repeated small-scale planting. Tests on soil structure show organic content that is higher in certain thin patches. That change in the soil is what a gardener would leave after years of tending a few trees or vines. These signals do not indicate large fields, but they do show local cultivation or maintained trees close to houses and work areas. Dating methods help place each step in time. Radiocarbon ranges on short-lived plant bits return spans that fit the early 1st century for some plant layers. Optical dating on sand grains supports a broader bracket that matches earlier use before major Roman rebuilding. Pottery sherds and coin fragments from closed pockets help narrow some levels to specific centuries. When multiple methods match the same layer, the timeline becomes more reliable. This sequence explains why an early text can speak of a garden near a tomb. The plant record and burial cuts align at the landscape level without linking a single grave to a named person. The evidence is about place and use, rather than about identity. That subtle difference matters for a transparent study. Clear steps follow from the view. Builders cut stone. Households used parts of the rock for burials. Soil was collected, and trees or vines grew in patches. Later communities honored a place above these layers with a small shrine and a chapel. Each step is visible in the layers and in the material left behind. What can further work show? Wider sampling across adjacent squares will test how large the planted area was. Seed DNA work may reveal whether olive and grape types were cultivated varieties. Soil chemistry can show whether gardeners added compost or used waste to enrich the ground. Mapping the reuse of carved stone across nearby structures can show trade in materials and common building habits. The publication of raw lab numbers and sample codes will let outside scholars test models and propose alternatives. Peer review helps correct mistakes and refine dates. Open sharing also supports local authorities who must balance repair with protection. This angle keeps claims modest while making the site easier to read. It ties botanical traces, burial cuts, and reused stone into a single human-scale story of work and daily life. The sequence is not a proof of a particular individual. It is a clear picture of how people used one small corner of Jerusalem across many years. Records and future studies will continue to refine the timeline and improve public understanding further. Thank you for watching. Please like, comment, and subscribe for more.